Starting with that, let's continue with our class today, which is continuation to what we started. So what we have talked about so far, we have talked about the 5 phases of system development life cycle. And we said the planning was the first phase, and thankfully it has been done for us. And what is done in the planning phase is to identify the problem. And then in the analysis, you identify several solutions and you make a decision on the best solution that can be appropriate. And that has been done for us as well. So the decision or the solution has been decided for us that they are going to go with the Microsoft Access solution that you as consultants are going to create and develop. And the third phase is the system design. And the system design involves 3 outcomes or 3 models that we will come up with. So far we have come up with the conceptual model. So what we did in the conceptual model, we identified the data elements that are needed for our project, for our database. How did we come up with those data elements? We used several techniques. We used observations, we read business documents, we interviewed end users as well as managers, and we also surveyed. Although we might not have surveyed here, but those are the techniques how we extract those data elements. And within the interview, we looked at 2 specific techniques that can allow us or help us identify the entities. And those are entity identification technique as well as characteristics identification technique. So what did we do? In the entity identification technique, we asked a broad question, open-ended question, to the end user or to the manager, and we asked them how do you perform your work on a daily basis? And you ask me that question. And the end user will answer that question broadly. They will keep talking and talking, but for me at least, I use maybe 1 or 2 sentences to answer that. And from there, and this is what we did. So I summarized it here. So that was the question that we used to identify the subjects or the entities. And we say that entities and subjects and tables, they have all similar names, and those similar names can include objects. So an object is a table for an entity. Also, we have subjects here that helps us also identify those entities. So how did we identify those entities? We say any subject in those sentences that the end user or the interviewer would answer and mention, we will underline them as possible entities. And that's exactly what we did. We highlighted it, and we looked at each one of those subjects. So we discovered those entities. And then when we looked at those several entities, we decided that we need to know more about each entity. We needed to understand the characteristics, the attributes of each, or which will become our fields for each of those entities or tables. And this is what we did. We asked another question, and this question is, you can ask it in any way you want, but for me, I prefer asking this question in this way. Talking about professor, what data is, or what data are needed? Data is a plural. So talking about professor, what data are needed for the professor? So what data are needed when we discuss the professor entity? Just throw some. So the class they teach. What else about themselves? Their name, first name, last name, middle initial. Maybe they have an ID, and that ID can be a potential primary key, isn't it? So those are some of the We need to know their specialty. We need to know their email. At least for this specific part, we are kind of assuming that we are building this database for the university, let's say. But it is very simple. So there are so many entities that I haven't mentioned, but I'm just mentioning those simple ones. So we need to know the rank of the professor. We need to know their specialty and email. So let's say those will be enough for us. And then we have other entities that we have kind of identified earlier. We have classes, we have courses, we have departments, and we also identify rooms, which means classrooms, and so on. So after we answer all those questions, identifying and extracting the characteristics or the attributes for each entity, we try to group them into a group that we can call it an entity. So after we discovered or we try to discover all those data elements, we just sketch them in a mind map. And this is what we did. We created a simple mind map that tells us some of the data elements that are needed for our database. Just throw it out there. From its name, just helps us think better. Now, when we are done with the mind map, we need to put it in a class diagram. So that means we need to group those, each entity with its own characteristics or attributes together. So you can put it in this format, in similar format like this. This is kind of an initial way of creating a class diagram. First, you group those entities with their attributes, or those entities with their fields that we are going to use them later on in a table. So we need to collect some information about the student. So what is important, what we need to collect about the student? You can see here that are the relevant information about the student. What if in the interview when you ask me that question, I said I like to eat, let's say, fish. Would that be also included in one of the entities? Fish would be an entity? Yes, it is an entity. But is it relevant in this database? It is not. So that's why we select only those relevant entities. And if something that is not relevant, that is not needed for us to do our job, then we ignore that entity. So that's the first step. Now we put it in a class diagram. So all of you so far have access to Visio. So this is what you will need to create. To create every entity with its attributes into a class diagram in this format. And then you will connect it. So when we look at those entities, then we need to think about the relationships between them. Just by looking at them. What is the relationship between, let's say, a professor and a class? Who can tell me, like, what is the relationship between professor and a course or a class? That's correct. So the name of that relationship is teaching. So a professor teaches the class. And then, so this is kind of the initial term that we will need for the exact relationship. And then we need to use cardinalities and modalities. Remember when we talked about cardinalities and modalities? So we will come to that. But let's now think about the relationships between those entities. So what is the relationship between, let's say, room and building? Classroom and building.
Room and building.
Perfect. So a room is contained in a building. And a building contains a room or rooms. So that's correct. So that's the exact term that we need for this relationship. So now we got the idea what we mean by the terms for relationships. Just to add to the names of tables, entities, objects, also relations. Relations also refers to a table or an entity. Just to add that. But now we are talking about the relation terms. So the relationship between those two things. How about a professor and a department? What would be the relationship between professor and a department, in your opinion? There might be several, but let's think about one that is very common, that comes to your mind.
The professor belongs to a department.
Okay, so all works in a, so a professor belongs or works in a department, and every department employs professors. So now we got the idea that we have terms that you can create them yourself. And those terms also come through the business rules, through the interviews, through the data collection that you have collected. That would help you kind of come up with those relationship terms or terminologies. What about the relationship between class and course? So there is a course and there are different classes. So let's say that I'm teaching a database course, but I have different classes. I have face-to-face class, and I have hybrid class, and I have an online class. So now every course has three classes, and every class belongs to only one course. So we came up, so we already discussed those relationships, and this is kind of the overall uh, diagram that we can look at. I hope that you can see it. If not, it is available. Those slides are available in Blackboard, so you can see them better. With this one, just more, sometimes it works, sometimes it doesn't. Uh, so now we can see here, we have connected those entities with each other, and we also included the terminologies between those entities. So you can see that professor or the department employs professor. So I didn't mention the cardinalities yet or the modalities yet, but so far you are all familiar with it because we have covered it. So let me do one uh, cardinality for you, and then I will ask every two of you to work on the cardinalities and modalities between two entities. So let me start with an example. So what I'm going to do is the relationship between professor and department. So this is the relationship between those two entities. I'm going to create the modalities and the cardinalities using the class diagram. So what I will do, I will just use text here, and I'll put it here next to the professor. So, and I want to know so the way we read those relationships in terms of cardinalities and modalities is we say every department, because employees here is next to the department, so that's how I would read it. Every department employs, is it how many? Is it 0, 1, or many professors? So every department employs at least one or many professors. Is that right? So every department employs one or many professors. So let's say or is it one? Do you think every department in the university employs professors or not? Not all of them, is that right? In the physical plant, maybe they don't they don't need to employ a professor. So what would be the relationship there? 0. So every department employs 0 or many professors. Can we say that? Is that kind of fair to say? So let's put that we will put it in here. So we will say 0 and then 3 dots between them. And then I will say star. So the star sign refers to many. Other people use the M or N, but let's use this one for the class diagram. So that's how when we read it one way. How about reading it in the other direction? So we say now every professor is employed by one department, or zero department, or B? Which one would you think is scale? One? One and only one? So that makes sense. Every professor is employed by one and only one department. So this is how we will illustrate it or depict it. So we'll say one, three dots, and then one. So this is done for us. So now I will ask every two of you to work on only one relationship between two entities, and then report it to the class. So you two, you will be working with the professor and student relationship. You will be working with the student and department, and you will be working with the student and class. And two of you, well, let's two of you and then two of you. So two of you will be working with the class and room, and then two of you class and course, and then two of you will be the building and room, and then three of you, I would say, department and course. Okay, so let's do that. So I'll give you 2 minutes, and then we will see the report from each one of you.
Well, I guess maybe one. No, that's the other two and what they have zero. Like balance.
Oh, yeah, yeah.
Yeah. Or there's whatever department like not all professors are all.
Okay, so it seems to be everyone is done? Okay, great. So now let's see every team what they can tell us which entities they were assigned and what they got. So let's start with the first team.
We put every professor advises one or many students.
Okay.
And every student is advised by one or many professors.
Okay. So when you did that, that's based on your assumptions, which can be correct, which might not be correct. So what you did is fine, but we need to understand the assumptions. And to do that, that's what we also learn from the business rule. So when you interview the professors and so on, you will understand it better. So in that case, you will have to interview more, or you will interview the professor or the department chair to understand more about it, to decide what it is. So what I would say is, from my opinion, because I'm working there, so I would say every professor advises zero or many, because they might be new and they are not assigned a particular student to advise. Yeah. So I would say zero or many. And then the student to professor, so we would say every student is advised by one and only one professor, because if they have too many professors advising them, then they might graduate after 7 years. Is that right? Because everyone will give them ideas about which courses to take. But at least in our department here, we are very small and we know exactly what courses you take. But if you are in a big university, then everyone will ask you to do something different. So that was great. So at least you did it at attempt and you were close. So that was your assumption. So let's look at the second.
We have every student majors in one or many departments, and then every department has zero or many students.
So that's also based on the assumption. It is correct. So your assumption that double measuring is allowed, and I doubt that in our HIM department. I don't think, or in the PMC, I don't know if that's allowed. But for me, I double measured, so I was able to uh, get two majors from two different departments. But here, I don't think it's allowed. So in this case, we would say every student majors in one and only one department because it's not allowed. So remember now? So now did it make sense what we mean by business rules? It comes in these places when we decide the relationships or the cardinalities. So every department has, you said zero or many students, based on our assumption, that's when we talked about earlier, that might be correct. And we might, based on other assumptions, it might be one or many. So, but that's correct. So one thing that I want you to understand is there is no one absolute truth and one absolute wrong. It's either right or wrong. It can be gray, as long as you explain your assumptions. So in this level of education now, when we were in elementary school, we need to know whether this is an apple or whether this is an orange. They cannot be something different. But at this point here now, you can say this is not an apple, and you prove that it is not an apple by evidence, and people will agree with you. So you have to have that evidence or assumptions and explanation why you think that's so. So let's look at the third theme.
You said every class enrolls one or many students, and every student enrolls in one or many classes.
So let's say that again. So you looked at those two, is that right? Class and course?
We had student class.
Student and class, okay. So what did you say?
Every class enrolls one or many students,
Oh, it's okay.
and then every student enrolls in one or many classes.
Classes.
Wouldn't our assumption then be that, like, if you're not enrolled in a class, then you're not a student here, and if the class doesn't have anyone enrolled in it, then the class is like therefore canceled and not a class anymore?
So we'll keep that in mind, and then we will see like what we have. But that's based on your assumptions that legitimate. So let's look at the second, the fourth.
So you have each class has 0 to 1 room, and every room can have 1 to many classes.
So every class can have zero or so assuming that you have online courses.
Yeah.
So that makes sense. So that's your assumption. All right, and then every room
That's 1 to many classes.
is assigned to. Every room should be assigned to only one class. Is that right? Or many? That's true because it might be in different times. In different times. Is that what you assume? So that's
This room
also.
will be utilized just for one class.
So perfect. That would work as well. So we will see what the solution looks like. So now let's look at Derek and Diana.
One, so every class has one course, but every course has zero class.
Okay. So we will move on. So we'll see. Let's see, Natalie.
We've got every room is located in one and only one building. Every building is located in one or more rooms.
Okay. So let's look at that. Third.
So we have, every department offers 0 or many courses. Every course is offered by one or only one department.
Okay. So let's look at what the solution here might differ a little bit from what you have, but those with the assumptions. So let's look at this one here. And then you can fix what you had based on this. So which ones were different? Theirs were different from what we have here. So yours was different. So yours was between,
Because we had that you could be in one or many departments, and then we decided to group up, which is still have one and only one.
the student and department? Okay. So here it says that every student majors in one and only one department because the assumption. So we mentioned that. And then every department can have one or zero or many students. So Derek, so was yours correct? Diana? It was? So which one was yours?
Course class. So
Course and class,
it
okay.
said every course has 0 to many classes. It's one.
So yeah, so that every course has to have a class. So that's kind of, logically, it makes sense. And then every class should belong to one and only one course. So which you got it right, that. So great. So what was yours? You already talked about it.
Yep, we did this.
Kelly?
Ours is different. Because we said there has to be one. We said one to many, not zero. But I don't understand how it's zero.
So which one was yours?
Student and class.
So, okay. So here it says student enrolls in 0 or many classes. That student may be in Oregon, so that's the assumption. The student is just maybe, let's say they got pregnant and they decided that semester not to take classes. So they are still students, but they are not taking classes. So that would be our assumption. Does it make sense? Maybe they are injured, or so. I don't like to say negative, but let's say those are kind of the reasons why we might have that difference. And then every class is enrolled by 0 or many students. So there are some classes, maybe they are not offered in that semester. For example, a database is not offered in the fall semester. So that's why we have 0 or. So your team? So what was different in your?
Well, the only difference we have is that the class is scheduled to only one and only one room. But if it's an online course, it's an assumption it would be a room.
Can you say that again?
Like on there it says, like each class is scheduled in one and only one room.
Okay.
But if they're in an online course, they would have a room scheduled.
So that's, yeah.
Zero
That's,
to one, not one.
so yeah, depending on the assumption, it can be either way. So let's see the next team. Natalie?
We have it, the only one we put it has located one or many rooms, and we have 0 or many rooms that are located.
Because there are some buildings, maybe For me, I worked in the maintenance when I was a student in the summer, and then we had a building that was a hangar. That was it doesn't have rooms. It's just all kind of only one space. So maybe that's the assumption here, which might be logical. So every building might have zero rooms or many rooms. So we'll assume that. That's what they.
Well, if it's, I mean, if the building has 0 rooms, it wouldn't be a building. Because it would have to be, I would have to be just one big room, still one.
So that's a good suggestion. But let's say that here what they meant by room meant classroom. Would it make better sense now? If it's a classroom, yeah, maybe some buildings they have research labs like Hemingway. I don't think they have any classrooms, but they have just conference rooms. They have research labs and so on. But so that would be maybe the assumption. So the last team, yours was correct. Okay. So now this is what we have. So now we are done with the cardinalities and modalities. But now we will move to the second phase or model that we are going to need. So this will be kind of our logical model where we decide the modalities and the cardinalities. Now we will need to decide how we are connecting those entities. So remember when we say that we are going to connect those entities, how are they going to be connected by? Uh-huh. So how are they going to be connected? How are you going to link those entities or tables? Primary keys and foreign keys. Perfect. So now, in this case here, I don't see any connection between those two guys. Do you see? Are they connected? Is there a foreign key in one of them? You see this in terms of this relationship? So that means they are not connected yet. But chemically or conceptually, we connected them. But are they ready to be tables yet? So in that's a process that we are going to discuss today. How to decide where the foreign key will be located. So that's our main purpose of today's lecture is to decide where would be the foreign key located. Is it in this table or we will put it in this table? So to do that, we have rules of thumb, and we will go over those to decide where we are going to put the foreign key. So let's look at this. So now we are in the process of converting entity relationships. So that's what we had, entity relationships so far. We are going to convert them into tables. And to convert them into tables, we will need to first distinguish between the cardinalities between them. Are they many to many, one to many, or and so on. And we want to connect them through a foreign key. So now this is a table that we have, or this is an entity that has several attributes, and by default you can say that the best primary key for this table is the salesperson number. So anything that has number code or ID can be a good candidate for a primary key. And we need to convert this into a table. This is how it would look like when we convert it into a table. But in order to convert them or to decide where the location of the foreign key will be, we need to look at the different types of relationships. So we have binary relationships, we have unary relationships, and we have ternary relationships. You remember those? So we will go over them today. So this is an example of converting one-to-one binary relationship. So when looking at these two entities, what is the relationship here? Can we say it is one to many, zero to many, 1 to 1 or what? How can we decide what is the relationship between those? So the line is the circle, so we look at the cardinalities, means the far ends. So what is the relationship between those two? So 1 to 1. So we can say this is a 1-to-1 relationship. Okay. And the 0 and 1 here, those are the modalities. So now can we decide where we are going to put the foreign key? Can you see now a foreign key? Are they linked yet or not? They are not linked yet because we don't see a foreign key in either one of those. So every entity here has its own attributes, and the same thing goes here. But they don't have the attributes from the other table. You remember when you did your assignment, when you connected those relationships, you connected one attribute from one table that exists in another table, which is the foreign key, in order to link them. But here they are not yet. So we need to decide which foreign key to put where. So what do you think? Just throwing an idea.
Office number of the salesperson.
So office number in the salesperson, you want to put it here. So do you have kind of a rationale for it, or just an opinion? Just an opinion. So that's a possibility. So the other opinion will be to put the salesperson number in the office table or office table, let's say. Is that right? That's another way. A third way is to combine both of them together into one table, which is not a good idea. Because by understanding from our understanding that a salesperson is an entity by itself, and everybody knows that. It's not only that, but also salesperson is connected to other entities and to other tables. So we don't want to mix them up with Office, and then we will have redundancies. And we say the main purpose of creating a database is to reduce redundancies. We don't want redundancies. We don't want less efficiency. So we want them to be, every single cell value has to be used and used efficiently. So we don't want to waste size, density, and so on. So now, as we mentioned, we have three options. One option is to combine both of them, which is not a good idea. And the other option is to convert those two entities into two tables. So this is how it will look like if we combine them. So remember when we say the every office belongs or contains 0 or many salespersons? Was that one way to read it? And every salesperson has one and only one office. So that's how it was. So when we read from office to salesperson, we read it that every office belongs to 0 means some offices are empty. So belongs to 0 salesperson. That means there are some offices that are not occupied. So in this case, if we combine the two tables, we will have office number 1 that is not linked to any of the salesperson, and then we will have no value for the salesperson number, no value for this name, and so on. And we will have only data only or field values for only office number, telephone, and size. Would that be waste to have empty cells or null values? Yeah, that's a waste. We don't want that. Another thing is a salesperson here is telling me it's underlined, which indicates to me that it is a primary key. So what did we say about a primary key? Primary key can never be null. So every primary key can never be a null value. So that means if I have office number 1 that is not occupied by any salesperson, then I will not have anything to do with it, which not allowed. So that's the problem. why we can't combine those two tables together. So the other solution is to create two separate tables and include the office number as a foreign key in the salesperson. So this is the third option, which Mario said, and it is a perfect answer. It's actually the perfect answer for this. And the third option is, which is the opposite of what you say. Which we say it is possible. Why it is possible, but it is still a waste. But it's not as bad as combining all of the two tables together. This option here, if we say every office is assigned to zero or many salesperson, so in this case here, if we have in the office table, we will have office number 1, telephone number, whatever that number is, and then salesperson will be null. Since it is a foreign key, it should not be a big deal, at least it will be null. And then the size will be a value. So that means, in this case, we will have one cell value that is not used, that is null. That would be also, we already assigned it a size, that means we are still wasting. So we assigned it some values or some space, but we are not using that space. So that's waste, isn't it? It is. So that's why we don't want to go or to put the foreign key in the office table. I'll give you a simple way to recognize where to put the foreign key. Just a rule of thumb. So if we have a binary relationship, that means a one-to-one relationship, you want to put the foreign key in the zero side. Okay? So if we have a one-to-one, we want to put the foreign key in the zero side table. So in this case, which one is going to be? So the foreign key, where are we going to put it? In the salesperson, because it is in the zero side. So is that simple? Makes it much better? So now, having understanding, or having that we understood all the reasons why we should not put it here or combine both of them, and why we put it here, then this makes it very simple for us to remember. Now looking at another relationship here. We have one-to-many. So we have one-to-many relationship. Is that right? Or I'm reading it wrong? Everyone is sure? So one-to-many relationship. Now, who can tell me their opinion? Where should we put the foreign key? So far they don't have a foreign key, either one of them. So where should we put the foreign key? So I'll let you discuss among yourselves and see what's your opinion. What's your opinion? So the customer? Okay. So do you have a rationale? No? So, but she got it right. Like Mario, you got it right. This is perfect. And I will give you the rule of thumb for this one as well. So if we have one-to-many relationship, you put the foreign key in the many side. Is that very simple? So if we have one-to-many, you put it in the many side.
On the what side?
Huh?
On the what side?
In the mini. So this is the mini, the cross leg. Is that what we call it? So we will put the foreign key in the mini side. So what do you think will be the foreign key here? Who can tell me what the foreign key we will put here?
Salesperson number.
Perfect. So when we take the primary key of one table, we put it in a different table, that's what we call it foreign key. Perfect. So that's exactly correct. So now we understand where to put the foreign key, because this is a major decision to make. And why do we care about this, where to put the foreign key? Is to reduce that waste, make it more efficient. and to also be more efficient when we are concerned about the data integrity. What do we mean by data integrity? Means if we are going to update anything in the salesperson, we will update it only in the salesperson table and automatically will be updated in this table for the foreign. So that will save us a lot of hassle. Because in some cases, you might have to make changes, just if we have a different system, you will make changes here in the salesperson, and then you will have to remember what table this table is linked to, and then you go to that table. So it is messy. But in this relational database, the good thing about it is if you want to make modification or update, you do it only in one table, and it updates it into all other tables automatically. So that's the good thing about using a relational database. And that's why we care about where we put the foreign. Okay? So now we understand and we know that the foreign key will be in the middle side. And the justification can be in this way. Now what if we have a many-to-many? Is this many-to-many or many-to-one? What do you think? It is many-to-many relationship. Why? Because we take only the cardinalities when we decide about the naming. So when we have a many-to-many relationship, where should we put the foreign key? So I want you to pause and think. Okay. So just to give the answer, when we have a many-to-many relationship, many database management systems will not are not compatible with many-to-many. So they don't allow many-to-many. So that's one thing to understand. And to avoid this problem of having many-to-many, we need to create an associated entity. So we need to have to create an associated entity for a table ourselves. And that associated entity will contain a composite primary key. So when we say composite from its name, that means it's composed of two or more. So in this case, the composite primary key will be this part of it will be the primary key from this table, and the other part of it will be the primary key from this table together in this associated. So now we need to understand that many relational databases, database management systems, they don't allow many-to-many relationships. And they don't support that. So that's why we need to create that associative entity. And this is how it will look like. So we have quantity. And then if I want, I will need to create the salesperson number into this entity. And the product number, I will put it here. And both of those two attributes will be my composite primary key. So they will work as a primary key, part of a primary key, as well as a foreign key. So is it clear now what we mean by that? So if you still want me to talk more about it, what do you think? Is it clear or some more? So, okay. So when we have a many-to-many relationship between two entities, then that's not supported by any database, relational database management system. So what are those database management systems? DBMS. What are those examples? Is Microsoft Office, Microsoft Access, SQL Server, MySQL, Oracle, and so on. So those, they don't allow to have many-to-many relationships or tables with many-to-many relationships. To avoid this problem, so that way we don't have that problem, we need to create a new table and call it associated entity or associated table. And this associated table will consist of the primary key from this table and the primary key from this table. We will put them together. I hope that I can write. I don't know if it will allow me to write. So I'll put here product ID or number, and then I'll put dots because it works as a prime part of the primary as well as a foreign key because we are borrowing it from a different table. So it works as a foreign key as well. Is that right? Because it's a primary key somewhere else. So we'll have a product number and sales number. So those will be our composite. Is it clear now? And then the quantity, that's nice, we have a quantity here. We can even include dates if we want. That would be nice. So this is what we mean by associative. It is an entity, we created it when we have many-to-many relationship, and it consists of composite primary key. The composite primary key consists of two parts, the primary key from the one of the tables and the primary key from the other table, and they work as a primary key as well as a foreign key. Okay? Is it clearer now? Okay, great. So this is how when we converted, or we created that associative entity, we called it sales. You can just give it any name. It doesn't have. It's not like the Bible. You have to name it or contain it. You can't. So it is. We called it sales, and as you can see here, the salesperson number came from the salesperson table, and product number came from the product table, and we added the quantity. So now we have other types of relationships. Remember unary relationships, which is one relationship. Remember one of the examples was, can you give me another example other than the salesperson?
So if you want pieces to build something.
So if we have products, the products are pieces of or parts of another product. So you're right. So that's another example. What about the relationship between, let's say, father and son? Can we say every person is a father of zero or many sons or daughters and so on? So we are talking about one person. Here we are talking about a salesperson. So we are saying that who can tell me the relationship between those two, assuming or among this one entity, what is the relationship in terms of backup?
Salesperson is back by one.
So what would we say this relationship? Is it one to many, or zero to many? So it is one to one relationship. So that's perfect, and that's how we read it. Every salesperson is backed up by one and only one salesperson, and every salesperson is backed up by, and so on. So in this case, how can we convert this entity into a table? So if we have a unary entity, how do we convert it into a table? In this case, we will have only one table. So that means we will have all the elements that we have here, all the attributes that we have that belong to the salesperson, and we will add one more attribute. And that attribute we can call it backup. Backup number. This backup number can be salesperson number. Very simple. So is it clear now how we convert unary relationship? Now when we have, what about this relationship? Who can tell me? But it's already said that. So it is one to many relationship in terms of managing. So every salesperson manages zero or many salespersons, because that person, if they are not, if that salesperson is not manager, then they will manage 0 salesperson. And we can read it also the other way. In this case, how do we convert this entity into a table? We will do the same like what we did earlier. So we will create a table with all the elements or the attributes that we have here, and we will add a manager ID or manager number for a manager. And this ID can be this ID. So this here just tells you the rule of thumb, how many tables and so on. And now what if we have a many-to-many? That's what we mentioned about the product. So we said when we have many-to-many relationship for a unary entity, then we will have to have 2 tables because we have an associated. Okay? So in this case, we will have to create 2 tables with 1 associative entity. What did we say about the associative entity? We have to have 2 parts or composite primary key. So now I will stop here, and tomorrow we will talk, on Thursday we'll talk about normalization. But before, in terms of this chapter, but I want you to work on what you just worked earlier on. So now can you tell me, I want you to work in pairs and look, each one of you look at the relationships that you were assigned to and decide and tell me where you are going to put the foreign key. So it's the same entities or the same relationships that you were assigned, and tell me where you will put the foreign key in which table or in which entity. For some it might be already there, for some it might not. But if it is there, tell me that it is there. If it is not, then tell me where you are going to put it based on what we just talked about. So let's work with the same groups. ID, like for example, GOO. So number would be the same.
So it's already there. Essentially, it's already there.
So that's what I mentioned. Some of them they are already there. They are there. Just mention that it's there. So that's good. If you know the reason why, then you just apply numbers.
Or would you put like your professors?
Yes.
Well, yeah. It will. What's more specific? Oh, wait, yeah, I would say like one minute. So something in the schedule. Yeah, I don't know. You might give a professor and your.
All right, so it should be everyone have already decided. So let's look. So let's look at the first theme. I'm a right hand side because when I write from right to left in my native language, so that's why I start from right. So don't be offended if I didn't start from left to right. So let's start.
So since ours was a one-to-one relationship, we decided that you would put the
Can you remind us first about the 2 entities that you are working on?
professor and student.
Okay, professor and student.
Yeah. And
What is
so,
the relationship first between those two?
one-to-one.
So who can tell us?
Oh, one.
be one to many.
Yes.
Yeah,
So this is
sorry.
one thing, okay?
And then, so we'll put the foreign key in the student. Is that okay?
So is that what you decided?
That's what we decided, but.
What was the reason? Is there a rule of thumb that kind of helped you decide that?
You said put the foreign key in the table.
Perfect. So that's perfect. You're right. So you will put, what are you gonna put here?
Professor ID.
That's right. Because that's the time to do that. Perfect. So this is perfect. You read it correctly. You say it is one to many, and you decided that you're gonna put a point key in this. So let's look at that second.
Ours was the same, so we were student and department, which is a one-to-many relationship. So you take the primary key from the department, which is the one side, which is the department code, and put it in the student side as the foreign key. That's the other side.
Perfect. Look, third.
Ours was between student and class, and ours was a 0 to many. And so you take the,
0 to many? Is that right, everyone? Who wants to correct them? Please jump.
Many.
Yeah. So it is many, if you look at the maximum. When we read the relationships, we look at the cardinality, means the maximum. So in this case, it is many to many. So I will let you rethink about it. Now you know, discuss it, and then we'll come back to you. So now you know it is many to many. So decide what you are going to do with that. So let's move to the second, to the next.
We have class and room, and it's a one-to-many relationship.
Class room, okay. It is,
One-to-many
okay.
relationship, and you would want to put, well, it already has room number under the class, and like for the room can hold more than one classroom, so you want to put the room number under the class.
Okay. So based on the rule of thumbs, you put the foreign key in the many sides. Yes. So perfect. That's correct. All right. Let's look at the next theme.
Or the class course. And so it's a one-to-many relationship course class. And they already have the primary key of the course ID to the foreign key of the class.
Perfect. Got it.
We have room and building, and we put the building code in the room.
So what is the relationship?
Um,
Huh?
one.
It is one to many? Yeah. So we look at the maximum. So the maximum will be many, and then the maximum there will be one. So one to many, perfect. And there, what did you decide to put the foreign key? Perfect. So what's the rationale or the rule of thumb? So the many side. So yes. So when we have one to many, we put the foreign key in the many side. So good. That's correct. Yeah, let's look at the last theme.
We have department and course, which is the one to many. So we put department code in the course, which is the many.
So you will put the commentary in the course. Perfect. So let's go back to the theme that has the main theme, which is it the easiest one? Is it the easiest one that they got? The many? It's not easy, isn't it? So you have to do some work. So what did you decide to do? Where are you going to put the foreign key?
I don't know, what two tables do they have?
They have student and class.
so is that when we make
This is
a new table and make the associated?
You put over the student ID and the class ID, both primary keys and the substitute table.
Yeah, perfect. So you got it. So that's what you do. So the time helped to think about it. And thank you for your help, because that's correct. You will need to have an associated entity that will consist of the primary key from the student table and the primary key from the class table. And then you can add whatever information or other attributes you want. The example that we have here, they added, like, this is how it would look like. So it's not this one. But you will have an associative entity that you can give it any name you want. Here. So a student in class, you call it enrollment, you call it grade, you call it whatever you want to call it. So that will be an associative entity. Another thing that we didn't mention here in class, what if you have one-to-one relationship? One and only one and one and only one. Where would you put the foreign key? So that question one of my students asked me one time. I remember. Because it's on the slide. So what if you have one and only one and one and only one relationship? One-to-one. That's depending on how it would look like, that might be a solution. But another solution would be, that could be a good solution. But another solution would be to put them either way, on either side. It's based on your judgment. So if you have one-to-one, based on your judgment. And combining them, because we have to look at one example in order to see if we can combine them or not before we decide. But that's also another possible solution. So now, did we do all so everyone participated? So now do you feel comfortable now deciding where to put the foreign key? All right, so now your assignment for this week will be to create the logical model. So far we have looked at the conceptual model, the mind map, where you identified all the data elements for that project. And I am going to give you my own solution, just to look at it yourself. And this assignment, this time, it is going to be team-based. So previously, the mind map was individual project or individual assignment. This one is team assignment. And if you look at the requirements, it needs or it requires that you meet online somehow using Adobe Connect. How many of you have used Adobe Connect and you are comfortable using it? You feel comfortable using it as a team? Okay, great. So as team, you will meet for a little bit, and the kind of the transcript of your meeting will be part of the grades. So that will be part of it. And then as a team, you need to decide how you are going to create that class diagram. Class diagram, this is what we have. This is our class diagram that we just worked on. And in your logical model, basically you are going to create entities like what we did here. You decide which one is the primary key, and then you will decide where you put the foreign key, and you create those names, the terminologies for relationships between each table, and you decide the cardinalities and modalities. So basically you will create something like this. And I will provide you with my mind map. So, and on Thursday, we will go through the normalization process. But if you want to get started and give it a shot as a team, work on it as a team. And on Thursday, if you want to discuss with me what you have so far, I'll be happy to give you some feedback after class. But if you feel comfortable with what you have, and then that's what you that would be fine with me. So it's not required that you get back with me, but if you feel like you want to kind of double check whether you are in the right track or not, after class I'll be happy to look at what you have. Okay, so any questions? Yes.
So we are doing essentially this for the project, and do we assign all the cardinalities and things?
Yes. So yeah, let's say an example would be you have patient. In that patient, we have we identified several elements that are related to that patient entity. We have mentioned several of them several times. First name, first MRN, that's their ID. First, middle, last, gender, age, or date of birth, not age, because age is not a good thing to put. Because what if we came next year and the age is the same? So age does not change, but if we have the date, then we would be able to calculate the age easily. So let's say those are kind of the essential ones. And then remember when we met, we said one of the business rules or the requirements that in this database, every patient should have several phones types. So can you tell me now, kind of a hint, what is the relationship between phone types and patient? Huh? So every patient will have many phone types, and every one type of phones will be held by many, because every type can be held by many, isn't it? Let's say that you have a cell phone, the cell phone type, so it can be held by many patients, is that right? Many patients have cell phones. So that's how we read it. So now we come to that dilemma. Remember the dilemma that they got? They had many to many. Now what you are going to do? You know what you create, you do. And then you call it whatever name you want or you feel. So that's an example. What about address? Every patient, we said, should have more than one address in the record. Is that right? That's one of the reasons, because we say one is the contact, let's say contact information address. What is the contact? Their address outside the center and their address in the center. So those by themselves are two types of addresses. Is that right? So what would be the relationship here? So every patient will have many addresses, and every address belongs to only one and only one